whatever day it is, day after wine and cheese party. Our first talk of the morning is Joenio. Take it away.
Thank you. Today I'm gonna do a presentation about a live coding subject. It's a short presentation where I'm gonna do a short introduction about what live coding is, and I will do a live presentation playing some sounds to demonstrate how it works. And then in the first moment of this talk, I will present a little bit about the live coding community and what it is. Live coding is a technique where we can produce sounds or visuals or even mechanical movements or any kind of sensor who is able to be controlled by programming. Then live coding is a technique where you can do real-time manipulation of the source code to continuously change the sound, the music, or visuals, or even also mechanical movements. Some people are using it with robots, or with also people doing choreographies and many other types of experimentations. The live coding community is organized around a community named TopLab that was created in around 2010. Then it has already more than, I think, 15 years or 20 years. And it is spread around the world. We have local communities. I am from Brazil, and in Brazil we have, for example, a big community named Algorave Brazil. In Argentina, Mexico, Peru, and Latin America in general, there is another community named Click that also is a huge community dedicated to live coding. And also, if you are from Latin America, for example, you can try to find the Click community. That's a huge community of people doing this type of thing. And besides the community, we have some kind of a format of event that's super popular, named Algorave. Is the type of event where people get together to play and to do live presentations using live coding tools and live coding programming techniques and etc. In this website, algorave.com, for example, we can see an agenda with the next events. Usually people add in this list events. If you are interested, you can check this website to find local events dedicated to this type of technique. In this, we have a bunch of different tools. One of the super popular tool is named Super Collider. This tool is open source free software tool. It's packaged in Debian. It's available in Debian. You can install it with apt install Super Collider. And Super Collider is a sound engine and also a programming language where we can manipulate somehow the low level of the electronic music principles. We can create oscillators. We can program new instruments. For example, I can create a specific kind of sound defining exactly the type of sound I need in this tool. Then this tool is super powerful, and it has a language that is more or less based in object-oriented language, but it's not completely object-oriented. But for example, it's possible to create anything. And On top of this tool, we have other tools that has more user-friendly syntax. And one tool that I like a lot is the tidal cycles tool. This is the tool that I use mainly. It's based in Haskell. Then the language is super expressive. We can do a lot of things, writing a few lines of source code. And this is the tool that I will demonstrate here mainly. But this tool, I will use it in combination with another tool that I am developing since, I think, 2 years ago, named dublang. It's a NeoVim plugin. It's a plugin for the text editor NeoVim, written in Lua. And this is what I am using to play Super Collider or to play with tidal cycles, or I have plugins created for many others tools. The idea that I had creating this dublang NeoVim plugin is to have a way to explore, especially the tools available on Debian. Then each time I have time free, I try to find a new tool. I try to see what is packaged in Debian, then I explore it. And if I find something interesting, then I create a new plugin to integrate on the dublang. For example, I have plugins, for example, for tidal cycles, for Super Collider, but also, for example, I created a way to plug the voice synthesizer, for example, the A-Speak. Then I can, through the same session where I play tidal cycle Super Collider, I can also send messages, send commands to synthesize the voice. I will demonstrate a little bit it now, for example. Then I am here in my terminal. I already started the service. Then I have Pipewire running here. Then in Pipewire I can see that I have already Super Collider is running, and tidal cycles is running plugged on Super Collider. Then Super Collider is who does the job, who does exactly the job, who sends the audio signal to the output. And tidal cycle is just a language on top of it. That's why tidal cycles doesn't appear here, because tidal cycle is just a programming language. But Super Collider is a programming language, but also a sound engine. And it has a client-server architecture. That's how people create new languages on top of Super Collider. There are a bunch of other tools doing more or less the same thing as tidal cycles. For example, there is one tool based on Python named Foxdot. And recently Foxdot was deprecated and the community forked it in a new language named Renardo. Then if you like, for example, Python and you would like to try, you can try. I would recommend Renardo. I have it in my to-do list to start packaging it as soon as possible. It's not available on Debian yet, but this is based on Python. You can program in Python syntax, manipulate the sound engine provided by Super Collider. Then, for example, I will use now the tidal cycles through the tidal cycles plugin I developed in dublang, the tool that I created. Then when I open the NV, it says, okay, it's connected to Super Collider, to tidal cycles, and it connects to the plugins that I already started locally. And then I can create different sections to send message to the specific language, to the specific dublang plugin. Then, for example, there is a background sound that I forgot to stop. Then here, if I write this code and I let my I let my cursor on top of this block of code. When I type Ctrl E in my keyboard, it evaluates this line of code, sends it to the Super Collider engine, and internally, Tidal Cycle's language by default works in an infinite loop. That's why I played it only once, and we are listening it in a loop, because this is the mindset of the Tidal Cycles tool. It's not the same thing for Foxdot or other tools or Renado. Each tool has a different way of playing it. But in Tidal Cycles, we have this internal loop that runs forever. Everything that I play, it's going to be played on top of this loop. And how the live coding technique works, I change the code, and I re-evaluate it, and then internally the language does a transition between the previous sound and the next sound. And then from that point I can manipulate the source code as an instrument, like a guitar, where I can improvise something live. For example, then the Tidal Cycles tool provides many functions. For example, a function to change the gain, or functions to change the pitch. For example, gain is the function to change the gain. Oops. But I can also change the pitch, play it more fast. Behind the scenes, what is going on here is Tidal Cycles comes with a library of samples. The samples are just folders and wave files inside those folders. There is a folder with a name CP for clap, and there is another folder with name BD for bass drum, and it's included in the Tidal Cycles library by default. And then I can use it, and I can manipulate the samples with the functions provided by the language. For example, I will keep the initial clap to demonstrate another kind of manipulation we can do. For example, I can, create slices of the sample with the function chop. Then didn't work pretty well. No. Yeah, sometimes live something happening different. I don't know what happened. Well, and this is Tidal Cycles only. And coming back to a bit to the dublang plugins that I mentioned, where I can play, for example, I can also send Super Collider syntax that will be evaluated by the Super Collider compiler, the interpreter. When I add this kind of, in the line 6, when I add this kind of header, I am declaring, okay, everything behind this line, below this line, is Super Collider language. Then, for example, I can create an oscillator here with frequency of 220. I can decrease the the signal a little bit, otherwise it's going to be super high. And I play it. Let's decrease a bit more. Then it creates a wave. I can visualize this wave in Super Collider. Super Collider is a language that also provides some functions to create a graphical user interface. People create a graphical user interface to create new instruments, and Super Collider also includes in itself the functions to provide some visual representations. We can see, for example, it provides this, it's provided by the Super Collider itself. We can say the wave being generated here, the sine wave generated by this line of code. Then I can stop everything here. And let me do a demonstration now. I will. Do we have time for questions after 20 minutes, or 20 minutes is the total? Total, okay. Then I will stop, I think, now to have a 5 minutes question. I think is more interesting than someone have questions? Curiosities? Otherwise,
we have a question.
You added a Super Collider block there, then you can use Super Collider syntax. It's going to connect to the Super Collider engine, the same engine that's running for tidal cycles. Is it possible to have code blocks calling other audio engines other than Super Collider?
Yes.
Yes?
Yes, it is possible.
Okay.
It's possible.
Nice, great, thank you.
It's possible. Let's see if it works. For example, it's not a sound engine, but it's the eSpeak voice synthesizer that I started here, for example. And then we're gonna see the eSpeech. eSpeech was not appearing here before because it appears only when I play the first thing. It is running, but it's hidden. I don't know why it doesn't appear when we start it. But when I play the first thing, it appears here. Then yes, now we have both, let's say, sound engines connected at the same time. Yes, and it's possible also to control external software synthesizers or even hardware synthesizers through MIDI using tidal cycles. Tidal cycles has some functions specific to connect, to do a MIDI connection with external synthesizers through MIDI or even OSC. In fact, yes, Super Collider provides OSC protocol connection. Then that's how tidal cycles communicate with Super Collider, is through OSC. And I suppose also the other, based on Python that I mentioned, is the same case. It connects through OSC.
Any more questions? We have a few minutes. You want to show one more thing?
Okay, let me play for maybe 1 minute or two. Yes.
Can I ask another question? Yesterday you played some movies also, and
Yeah.
you played that also from control from this.
Yes.
Oh.
Yes. I was controlling the movie player, the MPV movie player. That's software to watch movies through the dublang. Dublang has a plugin to control the MPV remotely.
I see.
Then I can change the video. And then I created it to myself a library of small samples of videos. And then during the presentation, I change from one video to another, or also I apply some effects provided by the MPV itself. MPV has, it's based also in the FFmpeg. Then I can apply many FFmpeg visual effects on top of the video, and I can use it from here as well.
Oh, nice.
Yeah.
Thank you. Thank you.
Thank you for the question.
And we're out of time.
I think we are.
Big hand of applause for our first talk of the morning.
Thank you. Thank you.